potential due to a point charge. Just like each and every derivation in your physics, we are going to have a diagram. This one has got a very small and very simple kind of a diagram. So what we have a positive charge, which is our source charge. It is placed at origin. For simplicity, we are going to assume our charge, our source charge will be staying at the origin, because if I take any other point, it will increase the complexity of the derivation. And we want to find out the potential at another point P. But before that, what our test charge is going to pass through? It is, let us say, it is starting from infinity. The test charge is coming from infinity and it has to reach this point P, and in between it is going to pass through 2 points. One is our point A, the other one is point B, and in between there is a small distance dx. So whenever we are going to take a small quantity, it will be either with a delta or a d. If it is kind of which can be measured kind of a thing, we are going to take it as delta. If it is something which is too small to be measured in a proper way, then we are going to just assume it to be a d. So here we are going to have a small letter, that is a small distance, that is dx. Now the distance from O to P, it is r, and at the same time I want to measure the distance between O to A, that I am going to take it as x. And the force, because of this charge, let us say that whatever the test charge it is arriving, and as I said, it will be always a unit positive charge, and I have assumed this charge also to be a positive charge. So what kind of force it will be? It will be a repulsive force, and that force is going to act in the direction of infinity. So a test charge is arriving from where? From infinity. To where? To this point P. In between it is going to come across these 2 points, that is A and B. So let us say that our charge, test charge, let's call it as small letter q naught, that is our test charge, is right now at position A. So if this charge, it was coming from infinity, it has reached till point A, then it will cross point B, then it will reach the point B. This is the situation. Now, for every derivation, after writing the diagram, after drawing the diagram, what you need to do is you need to write the explanation of the diagram. What is the explanation of this diagram? Okay, of course I will, in the notes you will get the complete derivation, complete description of the diagram, but I am going to just read out what is given in the diagram, because it is too much of text. If I write it, it will be completing the board. So I'll just read them out, and let us just call this as Q. You can take it a capital letter Q or a small letter q, but these should be distinct. This is Q, this is Q naught. That is our source charge, and this is our test charge. Consider a positive point charge Q placed at the origin. So we have placed it at the origin. Let P be a point at a distance r from O, where we want to calculate the potential. Potential calculate it is at point P. So we want to calculate the potential at point P. Now from the definition, what was the definition? Few minutes ago I had written it here. The potential at point P will be equal to the work done on what? On this Q naught. The work done on the test charge in bringing it against the field. Work done in bringing a unit positive charge from where to where? From infinity to point P. So it is the electric potential at P will be equal to the work done in bringing a unit positive charge from infinity to point P. That will be one paragraph description of the diagram. Then what is missing in this paragraph is about Q naught. That will be started in the next paragraph. A test charge Q naught is arriving. Where it is coming from? It is coming from the infinity. Is arriving from infinity to point P. Consider 2 points A and B in the path of Q naught. So they are in the path. The charge will cross these 2 points when it is trying to reach the point P. Then what we have, if this Q naught is located at point A and there is a Q located at the origin, what is the first thing that is going to be in between them? It is the Coulomb force. It is the interactive force, that is the repulsive force, because that is also a positive charge. This is also a positive charge. So there will be a force of repulsion between them. Coulombs law. What do we get from Coulombs law? It is the force between the two charges. So what is the value of force? It is F equals 1 by 4 pi epsilon naught. Q1, Q2 will now be changed to Q and Q naught. So it will be Q into Q naught divided by, what is the current distance? ಈಗ distance ಏನದ? It is X. It is not R. Coulombs law daga, it is the distance between the two charges. ಈಗ distance ಎಷ್ಟದ? It is X. So I am going to take it as X and that will be squared. Be careful with that letter X, because at the end we are going to get that letter R. So be careful with what distance you are using. Don't mix up with this X and R, because if you mix it, you are going to lose the marks. So now what we are going to do, from point A, it is going to move towards point B. When it is moving, what we need to do, we need to apply some external force. Because there is a repulsion, I will have to push that. I need to push this Q naught towards P. That means I am applying the external force. When I apply the external force, it is going to move from A to B. So what I did? I did some work. What is work? Work is force into displacement. Force I applied on this Q naught. And what is the displacement? Displacement is from A to B. What is the displacement given by? It is dx. So what we have? There is a small work is done in bringing or in moving the test charge Q naught from A to B through a small displacement, that is dx. Now I want work done. What kind of work it is? It is a small work, because I am not taking it from infinity to P. I am just talking between A and B. So I am doing a small work. I am not doing the large work. So I am going to take it as a dW. Work done is force into displacement. What is the force? Let's just take it as F. What is the displacement? It is dx. Now one small thing that will come here. What is the direction of force and what is the direction of displacement? Force is acting towards infinity. Displacement is acting towards the charge, towards the origin. That means what kind of angle is there in between them? One is facing towards right, one is facing towards left. F is going towards infinity, dx is going towards Q. It will be 180 degree. And if you know that the work done is the dot product of force and displacement. So I can expand that. It will be F dx into cos theta. Now what is the value of theta? They are in the opposite direction. That means theta is going to be 180. I am going to directly write that value. Now what is cos of 180? It is -1. So what is my dW going to become? dW will change to now F dx, and that will be 180 is going to give me -1. That -1 I have already multiplied here. So this is the equation for the small work done by the external force on this Q naught to move it through a small distance dx. I hope you are with me till here. Now if I want the complete work. Complete work means where I am starting. I am starting from infinity. Where I want to go? I want to go to point P. That means I need to add the work. Now, can I add it? Because I don't have the small distances. If there were small distances, I would have just added them, the first distance and the second displacement, third, fourth, likewise I would have gone. But that I cannot do here. What I can do here is, it is the smallest possible displacement, that is dx. So instead of going for addition, I am going to go for integration. So if I want w, this will be integration of dw. If I apply the integration onto this one, the minus sign comes out, f dot or f into dx. Now, do I have any value for that one? Yes, I have the value for this force, that is 1 by 4 pi epsilon naught q into q naught divided by x square. And one more thing I have got from the diagram is the starting point is infinity and the end point is at a distance of r. Now that r is going to appear, I am going to take the limits of integration. Starting point is infinity, end point is the small letter r. So I am going to apply the limits of integration. Yallinda start agbeku, it will start from infinity. Yallinda end agbeku, it will be at the distance r. Now I am going to substitute that value of f. So w will be equal to minus integration of, also I will write the limits, infinity to r, 1 by 4 pi epsilon naught. What is the value? Q into q naught divided by x square into dx. So that is going to be my equation of integration. Now, just as if, because the integration is not yet completed, I think in mathematics, just a brief about integration. If I get an integration of x into dx, it will be, the result will be x square divided by 2 into, it is plus c. That is called as constant of integration, and you can drop it in most of the cases. In this case also, we are going to drop that small c. Now, what is, if I want to generalize this, or I am going to take one more example, integration of x square dx. In this case, it is going to be x cube divided by 3. If you observe the pattern here, the power here was 1. If I integrated that, the power becomes 2. Here also, the power was 2. If I integrated it, the power became 3. And whatever is the power, the same thing appears in the denominator. And if you have gone through part of differentiation also, integration is reverse process of differentiation. So you will be able to understand this situation. So if I want to generalize this, it will be integration of x power n into dx. What I can write here is x power n plus 1 divided by n plus 1. That is a general rule of integration. So if there is x which is having a power of n and it is multiplied by dx, then integration is going to give me x power n plus 1 divided by n plus 1. Now, this thing I need to apply to this x square. Why? Because the variable here is dx. Because what is changing from infinity to this point P? It is only this dx. Dx, where it will be? It will be at infinity. Then later on it comes nearby. Then it comes near. Then it comes near. Till it reaches this point P. This dx is the only variable. Whether this 1 by 4 pi epsilon naught will be changing? No. It is a constant. It will come out of integration. Ade prakara, q and q naught are the values. Whether the values of that q and q naught will be changing? No. The charge will not change either on this position or in this position. So that q naught and q will also become constants only with respect to this dx. So all those quantities will come out. I am going to rewrite that equation. So it will be minus of 1 by 4 pi epsilon naught, and I can just write it as q into q naught integration of from infinity to r. What is that? It is 1 by x square dx. Now, what power I am going to substitute here for this n? There is a x square, but it is present in the denominator. If I take it up, what it is going to become? It is going to become minus 2. So, this is integration of x power minus 2 into dx. We agree? I hope you understand this step. This x square is there in the denominator. If I take it up, it is going to become x power minus 2. So I am going to integrate that x power minus 2 according to this equation. So this is going to become x power minus 2 plus 1, and then in the denominator again there will be a minus 2 plus 1. So what is going to become? It is going to become x power minus 1 divided by minus 1. That is what it is going to become after integration. So I am going to substitute that value in this one. So I am going to have minus q naught divided by 4 pi epsilon naught. Now the integration is going to give x power minus 1 divided by minus 1. I am going to put this inside a bracket and I am going to take the infinity in the lower limit and this r in the upper limit. Now what this is going to become? There is a minus 1 here, there is a minus sign here. So these two minus signs will cancel each other. That is one thing. Second thing, there is x power minus 1. Again, if I want to remove that minus 1, I need to put that x into the denominator. So this is going to become, minus is gone, q naught divided by 4 pi epsilon naught into 1 by x. This is infinity, this is r. Now what we need to do with that infinity and r? It will be substituted in the position of x. Wherever we get x, once I will be substituting the final position and once I will be substituting the initial position. What is the initial position? Infinity. What is the final position? It is r. So it will be upper limit minus the lower limit. So this is going to become q naught divided by 4 pi epsilon naught. It will be 1 by r minus 1 by infinity. So limits are applied. Now nothing is left. What is the value of 1 by infinity? It is going to become 0. What is left is 1 by r. So I am going to write the final equation here. This is going to become q into q naught divided by 4 pi epsilon naught. Only 1 by r is left. I can multiply that r to the denominator here. So it is going to become r. Now what we were calculating? We were calculating the work done. So what I have is W equals q into q naught divided by 4 pi epsilon naught r. Now what we defined for the potential? Potential is the work done on a unit positive charge. That means, what was the unit charge here? It was my q naught. This q naught, I am going to bring it here. Or you can think of it as dividing both sides by q naught. So what it is going to become? It will become W divided by q naught equals q divided by 4 pi epsilon naught into r. Now what is W by q naught? That itself is the definition of the word potential. So I am going to just put that V equals W by q naught equals, what is that? Q divided by 4 pi epsilon naught r. So that is my final equation of this derivation, that is potential due to a point charge. We had a single point charge Q. It was having a field which is going to oppose the test charge which is coming from infinity to this point P, and that region is going to be a potential. There will be a field, and if I move that test charge against that field, then it is going to experience that potential. What is potential? It is the work done on a unit test charge in moving moving that charge against the field to a point. So where I am going to move that test charge? To this point P. Where I am starting from? From infinity. So where we started? We started with the diagram. There is a source charge, there is a point P. Source charge is at origin, point P is at a distance of r. Then further we are going to have two more points A and B, and it is going to end up with an infinity. The distance from O to P is r. Distance from O to K is x. Explain the diagram. What is there? There is a source charge which is producing the potential, which is producing the electric field, due to which we are going to have a force. Then explain about the test charge which is coming from infinity towards that point P. Now what we are going to continue with that one? It is going to be from Coulombs law. That is going to be our first equation, in which we are going to use the force. The only difference is, instead of using letter R, we are going to use the letter X. Now going further, the work done. What is work done? Work done is force into displacement. What is the force? It is the Coulomb force. What is the displacement? It is the small displacement which happens between the points A and B. So it will be F dot dx, because work is the dot product of force and displacement. So we are going to multiply that, and because there is a dot product, I am going to take that cos theta, and because they are facing in the opposite direction, F is going towards right, dx is going towards left, the angle between them becomes 180 degree, and cos 180 gives us a -1. That minus I have multiplied here. Then what we were discussing till here, we were discussing a small work for moving that test charge for a small distance dx. Now instead of talking of that small distance, I want to talk of the complete distance. What is the complete distance? It is from infinity till this point P. What I need to do? I don't have small pieces of that distances. Instead what I have is a continuous line. So wherever there is a continuity, we cannot apply the summation, we need to apply the integration. So we apply the integration. For the total work, it will be the integration of small work. That small work, when we substitute the value, it will be F into dx, and that F substituted is going to give us 1 by 4 pi epsilon naught Q into Q naught divided by x square. That is the force. Then there is a displacement of dx, and then we are going to apply the limits. What are the limits? Starting point is infinity, end point is at a distance r. That limits will be applied to the integration. 1 by 4 pi epsilon naught, and also this Q and Q naught, they are constants with respect to this x square and dx. So they will come out of the integration. All those will remain outside. The integration only applies for 1 by x square. For now, you may get it difficult to understand this step because integration is not yet covered in mathematics. Once you are done with integration in mathematics, you will be very comfortable with this step. And also, because you have taken the screenshot, you must be able to understand how I have done that. Okay, so this is integration of 1 by x square between the limits infinity and r into dx. This is going to give me x power -1, or alternatively I can directly write it as, instead of writing this as 1 by x square, I am going to write it as -1 by x. Power will be reduced by 1. In differentiation, power will be reduced if it has a positive power. If it is a negative power, power will be increased in the differentiation. Whereas it applies in the other way around. There is a minus sign. There was already an existing minus sign. These two minus signs will cancel each other. What we are left with is Q naught divided by 4 pi epsilon naught. This x power -1, I can take it as 1 by x. Once I am done with those integration steps, now I can substitute the values of the limits. What are the values of the limits? It is r and infinity. It is always the final point minus the initial point, or the final position minus the initial position. That's how we used to calculate the velocity, or that's how we used to calculate the distances, especially in mathematics. For the straight lines, the distance of a line or the length of a line, it is final position minus the initial position, x2 minus x1. So likewise, the final position here is x. The initial position here was infinity. So integration between the limits r and infinity. Upper limit minus the lower limit. So it will be 1 by r minus 1 by infinity inside the bracket. All other terms will remain as it is. After that, 1 by infinity is going to give us a 0. What we are left with here is just 1 by r. And that 1 by r can be multiplied here in the denominator here. After that, we will go to the definition of potential. What is potential? Potential is the work done on the test charge. So W was our work done, Q0 was our test charge. We'll divide both sides by that Q0. So W divided by Q0 is going to be giving us our potential. What is left on the right hand side is Q divided by 4 pi epsilon naught into R. Now this W by Q0 can be replaced by a single letter, that is V, which represents the potential, or in this case it is the electrostatic potential. So W by Q0, what is left is Q divided by 4 pi epsilon naught into R.